Right, guys, this is part 2 of the review that we were doing for the topics 1.1 to 1.3. And I think there will be a part 3 as well because we have a couple of more pages. We cannot cover everything in today's video. So enjoy this. And if you need private tutoring, feel free to reach out. Also, please subscribe, do all those things, like and subscribe everything. Please, it will help. Okay. Right, there's a function given, a table of values are given actually, and we need to find out whether this is a linear or quadratic guy and select the correct reasoning. I hope you know this concept that the concept is if you have a table of values and if the x values are increasing by the same amount, right? So for example, here is 1, 2, 3, 4, 5, the x values are increasing by the same amount. So you find something called first difference. And if that is not equal, you find something called second difference. If first difference is equal, then it is a linear, and if the second difference is equal, that is a quadratic. So first difference is always latter minus former. So -5 minus -2 is -3. This is -3. This is -3. Well, we have a winner already. First difference is same, so definitely it's not quadratic. Now, why it is linear? Because ROC over consecutive equal length input values. Consecutive equal length input values means the x values are increasing by the same gap. Is constant? Well, looks like that. Yes, ROC is a constant. And the second option is saying that ROC is linear. Well, ROC is not really linear. Had ROC was linear here, it would have been quadratic, right? So that's the correct answer with incorrect reasoning. The reasoning is of quadratic. So ROC is same. That is the reason why this guy is a linear function. So option A is correct. Okay, the same question. So I'm gonna, what is that? Yeah, it's the same thing. So I'm gonna find the first difference. What is the first difference, guys? Here, just make sure that the x is increasing with the same gap, which it is. So this will be -2, -3, -4, -5. Now it makes sense. This is increasing linearly, so this is a quadratic. I can show you that the second difference will be same. -3 minus -2 is -1. This is -1. This is, -5 minus -4 is -1. So this is definitely quadratic because the second difference or the ROC is forming a linear model over here. That's what they are saying, that the ROC into ROC is actually linear. This is the ROC and it is linear. As you can see, it is increasing linearly. Okay. Okay, almost same question, I think, but options look a little different. Let's try this out. Still, they are asking whether it's linear or quadratic. No, actually, yeah. I mean, options are slightly different. So first difference, let's find x values are increasing by the same gap. So 5 minus 12 is -7. 0 minus 5 is -5. This is -3 and this is -1. Obviously, it's not equal, so the second difference will be -5 minus -7 is 2, -3 minus -5 is 2, -1 minus -3 is 2. Second difference is same, so I think this is the answer where they are saying that because the change in the average rate of change is constant, right? Option C is saying that the rate of change is constant. Rate of change is not really constant. If that was constant, this would have been linear. The change in the average rate of change is constant. Change of change. So second difference, that's constant. That's why it is a quadratic. So that's the correct reasoning. Okay. Again, a similar question, but you know what? Look at that. X values are not increasing by the same gap. So you cannot really blindly do the first difference thing. Now you need to make sure that if it is a linear, then slope between any 2 points is going to be same. So you can take any 2 points that you want, maybe the first two. So between first two, the actual rate of change is going to be y2 minus y1, y2 minus y1 over x2 minus x1, which is just 1 over 1, which is just 1. And let's take these 2 points where the ROC will be y2 minus y1 over x2 minus x1, which is 5 over 5, which is just 1. Excellent. ROC is same. So this is definitely a linear function because average rate of change is constant. Again, for the same reasoning as mentioned before, this is not the correct statement that average rate of change over each interval is linear. That's not correct. So option A is the best choice. Okay, here they are talking about concavity, right? Concavity, you can see that they are talking about concave up or concave down. So concave up, concave down also is based on the first difference if the x values are increasing by the same gap, which it is. Just find the first difference here. This is 6 minus 12, which is -6. This will be -3. This will be -2. This will be -1. What do you think? Is the first difference increasing or decreasing? Increasing, right? Because negative numbers getting smaller means overall the numbers are getting bigger. And when the ROC, because the first difference is now equivalent to ROC, and if the ROC increases, this means that the function is concave up. So it is definitely concave up. Why? Because average rate of change are positive? No, that's not the reason. Average rate of change is positive means the function will be increasing. That's the incorrect reasoning. There's option B is saying when the average rate of change are increasing. Yes, definitely. ROC is increasing. That's what we are looking for. It is increasing. That's why it is concave up. I think I'm going to skip this question because you get the overall idea. Here also x is increasing by the same gap and you can do the same thing. It's the exact same question. So I'm going to leave this question. I'm pretty sure you guys can do it. Okay, now these questions are the figure, we are given a function. Is this function increasing, decreasing? Okay, function is definitely increasing, right? Because while going from left to right, we can see that the function is climbing. And is the function concave, growing at increasing rate or decreasing rate? So these are fancy words of saying, is this concave up or is this concave down? Definitely it is concave down. It is frowning in nature, right? So increasing at a decreasing rate, that's the answer. So option B. Okay, over here they're asking is the function increasing. Obviously the function is decreasing as the x values are increasing, the function is going down, so it is decreasing. And it is smiling as well in nature, so it is decreasing at increasing rate. So increasing rate means concave up, so yes, that is concave up over here. Okay, over here we are again similar options. Is the function increasing? Yes, the function is increasing. Is the function concave up? Yes, the function is concave up because this is smiling in nature, right? So concave up and increasing, option A makes the best choice. Okay, the next one is over here. Is the function increasing or decreasing? Definitely the function is decreasing over here, and it is frowning in nature as well. So it is decreasing and nope, concave, not concave down, not concave up, decreasing and concave down. Yes, that's what we are looking for. So option D, I think, is the best choice over here. Okay. Here the same question with different wording. ROC is positive or ROC is negative? Remember, ROC positive means function is increasing and ROC negative means the function is decreasing. So here clearly the function is increasing, which means that ROC is positive. So it's either A or B. And ROC decreasing means the function is concave down, and ROC increasing means the function is concave up. So clearly this function is concave down. So A makes the best choice, that the function is positive, the function is increasing because ROC is positive, and the function is concave down because the ROC is decreasing, right? Okay, last question for this video. The figure over here is okay, that's the same thing. So is the function increasing or decreasing? It's decreasing, which means that the ROC is negative. And is the function smiling or frowning? It's smiling, which means that the ROC is increasing. So option C is the best choice. Right, guys, there will be a part 3 of this video as well, so make sure you watch that. And if you need private tutoring, feel free to reach out. Thank you for watching.